All right, so for section 2.2, we're going to start looking at some graphs of functions. And a lot of things we're going to do in this class. The graphing is a pretty important part of this. So it's a good idea to make sure you have the basic shapes of different types of functions that have to know what the basic graph looks like. We'll also get into how to transform these and move them around, flip them upside down, move them up or down or left or right, whatever the case may be. But this is kind of getting into the basics. So a lot of this stuff you probably have seen, especially this first one. But this is one skill that you want to make sure that you are very comfortable with, especially when you get into calculus. A lot of calculus is looking at graphs and analyzing graphs. So this is a very good foundational section that we're going to talk about here. So this first one, f of x equals 3. Most of you probably know that this is either a horizontal line or a vertical line. I know that when I was a student, I had trouble remembering, is it y equals 3 that's a horizontal line, or is it x equals 3 that's a horizontal line? Because the x-axis is a horizontal axis. So it seems like the x equals 3 would be the horizontal line, but that's actually not the case. The x equals 3 would be the vertical line. This one, which we could rewrite as y equals 3, this is going to go through. So there's where y is 3. And so this is going to go through that point. And just going to be a horizontal line like this. Now, one technique for graphing equations, if you have trouble remembering what a graph looks like, you can always make a table. And the more complicated the graph is, the more difficult this would be. You can still do it. It just might take more points to kind of get an idea of what the graph would look like. But this is a function. And so the x is the input. And so what you can do is you can just pick, this works with anything, any function that you want to graph. Just pick some x's and see what the corresponding y values are. So when x is -2, y is going to be 3. And so we can plot that point, -2, 3. When x is -1, y is 3. So we can plot that point, -1, 3. When x is 0, y is 3. And all the way down, y is going to be 3. No matter what x is, y equals 3. It's just definitionally, in this case, y equals 3. So 1, 3, 2, 3, 3, 3, 4, 3, and so on. And so that's how you can plot the points to give you the horizontal line. Now, this one, as you probably know, is a linear function, and linear functions are straight lines. And this is one that you would have learned to graph probably in Algebra 1. So we have the slope, and you can make a table of values on this, but it's not really necessary. And when you're on WebAssign, you really just have to plot 2 points. And so you could either pick any two x values. So we could do that. So just pick, because any 2 points make up a line. So just pick two values of x, and then plug them in. And so -2 times -2, that's -4, plus 1, that'd be -3. And then plug in 2 for x. 2 times 2 is 4. 4 plus 1 would be 5. So we have -2, -3, and we have 2, 5. And then we can connect those, and there is our line. Now, the other way to do it, which is probably the way you learned in algebra, the b here, the 1, is the y-intercept. So that's where it's going to cross y-axis. And then 2 is the slope, and 2 being the slope, you probably remember, this means we're going to go up to right 1. Up to right 1. So up to right 1, up to right 1, up to, so there you can get as many points as you need. But you really only need 1. one more. So you could either do it this way, where you just pick a couple of x's, find out the y values, plot those ordered pairs, and then connect the line, or you can start with the y-intercept and then move by whatever the slope is. Either way will work. And of course, on WebAssign, once you get 2 points, it will draw the graph for you. Okay, so those are, I'm sure, things that you remember how to do. So hopefully that will still be easy for you. So now we have three parent functions, we can call them. These are just the basic functions, basic graphs for these types of functions. So here we have a quadratic. And you can make a table of values. I'm not going to do that here. We'll just draw the graphs. We have a cubic, x cubed. That is a cubic function. Then we have square root x, which we'll just call the square root function. And you can make a table of values. And on the homework, a lot of times they're going to have you do that. We won't do that here. But you should for sure know that the quadratic, y equals x squared, looks like this. The cubic looks like this. And the square root function looks like this. And as we go along, we'll talk about what happens if this is x squared plus 2, or what if it's x minus 2 squared, or same thing here, what if this is x cubed minus 4, or what if this is square root x plus 2, where it's all under the square root, or what if it's square root of x plus 2, where the plus 2 is outside the square root. So what happens with those? We'll get to all those. For now, it's important that you understand and know what the basic shape of this looks like. So when you see a quadratic function, it is going to look like this, or it could be flipped upside down, but it has that same basic shape. Cubic, same thing. These can get a little bit more complicated looking, like you could have one that kind of comes up and then back down and then come back up. But it all has the same basic, they all have the same basic shape. Same with the square root. These for sure will just look like this, as long as we don't have anything weird going on in here, like x squared plus something. That makes them look a little bit different, but it's just kind of a linear part under the square root. Then it's just a basic shape like that. And it could be upside down. We could even make it come like this, or come down like that. We can move it up or down, left or right, any of that. So we'll get to all that as we go along. But for now, just make sure you understand these basic shapes. All right, so now we have a piecewise function. And so the piecewise functions, you graph these the same way, and you can still make a table. And the only thing you got to be careful of here is where are you plugging in your x, which we talked about this, and I think that's probably supposed to be a plus. I always forget to hit the shift. I type a plus for some reason. And we make a table of values. So let's just start at -2. And now notice that this one is split at 1. So you actually need to do the 1 twice, because that is where it is split. And so above that line, we are going to be using x squared. Below the line, we're going to be using 2x plus 1. The other thing to pay attention to, less than or equal versus greater than. So you're gonna, one of these will probably have an equal. They never will both have an equal. They could, it's possible neither one of them do, but most of the time exactly one of them will have an equal. So in that case, we are going to have a closed circle here, since the equal part goes with the less than. We're going to have an open circle here. And that's just kind of a mental note for when we graph this. So plug in the x's were less than or equal to -1. So we're going to plug these into the x squared. So -2 squared would be 4, -1 squared is 1, 0 squared is 0, and 1 squared is 1. Now, well, let's go ahead and plot these. So -2, 4, -1, 1, 0, 0, 1, 1, and we're going to put a closed circle there. And then we can connect these. We know what the graph of x squared looks like, and we're going to stop there. So once we get past 1, we're no longer looking at the x squared function. Now we're going to be looking at the 2x plus 1. So now 2 times 1, so we're going to plug the 1 in here. 2 times 1 plus 1, that would give us 3. 2 times 2 plus 1 is 5. 3 times 2 plus 1 is 7. So let's plot these. So 1, 3. Now, remember we have to put the open circle because this is just greater than. It's not greater than or equal. So let's put the open circle there. And then 2, 5, 3, 7. And then we can connect those like that. And we can put the arrow because it's going to keep going in those directions. It does stop here. It does start here. But that's how you graph the piecewise. So always make sure, where is it dividing? You need to put that on your table twice. And then you need to make sure you know which one is going to be the closed circle, which one is going to be the open. The closed circle is where it's equal. The open circle is where it's just greater than or just less than. Okay, we'll go ahead and stop here, and then we'll pick up the rest of the section on the next video.